Our session today is about central angles and measuring arcs. What do you mean by central angle? The central angle is an angle whose vertex is the same as the center of the circle. So the vertex here is the vertex of the angle is the center of the circle. And each side of its sides, we have two sides. Each one is a ray, the ray MB and the ray ME. The two sides of the central angle contains a radius of the circle. MB is a radius and the line segment ME also is a radius. Okay, the two sides of the angle A and B, which are the ray MA and the ray MB, divide the circle into two arcs. As you can see here, we have two arcs. The first arc, which is the red arc, is the arc AB. Okay, the minor arc AB, and it's denoted by AB, and we draw a small arc above the two letters AB. Also, we have another arc, which is the blue arc here. This arc is called the major arc AB, or I can put a third letter like C here and read it as the arc ACB. So we can read it as the major arc AB or arc ACB, where C is a point on this arc. So the central angle is an angle which its vertex is the center of the circle and its two sides contains two radii of the circle. And this central angle divides this circle into two arcs. One of them is a minor arc and the other is the major arc. If AB is a diameter in the circle M, then the measure of angle AMB, this is a straight angle, so the measure of this straight central angle is 180. Then each of the two arcs AXB and AYB is called semicircle. So we have two semicircles. The first semicircle is the arc AXB and the second is the arc AYB, where AB is a diameter in the circle. So what do we mean by the measure of the arc? The measure of any arc is the same measure as the central angle which subtends this arc. If we have an arc, for example AC, the central angle subtend this arc is the angle AMC. So the measure of this arc is 30 degrees. Okay, so the measure of arc is the same as the measure of the central angle which subtends this arc, and it's measured by the measuring units of the angle, degrees, minute, seconds. This is the measure of the arc. Okay, from this figure we want to find the measure of arc AC, the measure of arc CD, DB, and DB the major, and AB. Okay, let's begin with the measure of arc AC. Look at the figure. This is the arc AC, and this is the central angle which subtends this arc. So the measure of arc AC equals the measure of angle AMC, so it will be 30 degrees. Let's move to measure of arc DB. This is the arc DB. This is the arc DB. What is the central angle subtends this arc? The angle DMB, which is 90 degrees. So the measure of this arc is the same as the measure of the central angle subtends. It's like, for example, here DMB equals 90 degrees. So the measure of arc DB equals 90 degrees. Let's move to the arc CD. This is the arc CD. Okay, here we have 90 degrees. So the summation of measure here is 90 degrees. So this arc, this arc equals the measure of the central angle CMD, which is 90 minus 30, which is 60 degrees. Or we can write 180 minus 90 plus 30, also it will be 60 degrees. So the measure of arc CD equals the measure of the central angle CMD equals 60 degrees. What about the arc AB? This is the arc AB, all this arc, subtended by the straight angle A and B. So the measure of this arc will be 180. This is arc AB, subtended by the three angles 30, 60, and 90. And of course, this angle is a straight angle because AB is a diameter. So the measure of arc AB equals 180. The arc AB is a semicircle. Measure of DB, the major. This is DB. This is DB. And where is DB, the major? Okay, let's see. DB, the major, this arc. All this arc. Okay, so this is DB, the major. So how can I calculate the measure of this arc? It's the same as the measure of the angle of the central angle. The same as the measure of the central angle. How can we get the measure of this central angle? It will be 360, all the circle minus 90 degrees. All this arc, it will be 360, which is all the measure of the circle minus this arc or this angle, which is 90 degrees. So measure of the arc DB, the major, will be 360 minus 90, which is 270 degrees. So we learned that the measure of any arc equals the same measure of the central angle which subtends this arc. The measure of semicircle, of course, will be half the measure of the circle. It will be 180, 360 360 divided 2, and the measure of all the circle will be 2 semicircles, so it will be 2 multiply 180, which is 360. We have two arcs which we call an adjacent arcs. We have two adjacent arcs. The two adjacent arcs are the two arcs in the same circle that have only one point in common. Here, for example, if we have the arc AC and the arc CD, they are two adjacent arcs. The arc AB and the arc BC, two adjacent arcs. But the arc AB and the arc AC, not adjacent arcs, because we have more than one point in common. Okay, so the arc AB and the arc AB and the arc BC are two adjacent arcs, like here. AB and BC are two adjacent arcs in the circle because they have only a common point, which is point B. So the measure of arc AB plus the measure of arc BC give me the measure of arc AC, or the measure of arc ABC. But the arc AC, this arc AC, and the arc BD are not adjacent arcs because they have more than one common point. Okay, AC and BC have more than one common points. For example, points B and C, they are common. Okay, what about the length of the arc? So we have the measure of arc, which we measure it by degrees and minute and second, like an angle, and this measure equals the measure of the central angle subtends this arc. We have another concept, which is the length of the arc. What is the length of the arc? The length of the arc means the part of the circle circumference proportional to its measure, and it's measured by length unit like centimeter, meter, and so on. So how can I calculate the length of any arc? The length of arc will be the measure of the arc with respect to the measure of the circle, then I'll multiply it by the circumference of the circle. So it will be the measure of arc over 360 degrees multiplied 2 pi r, where r is the radius of the circle. Pi, we know pi is the 22/7. Okay. If you want to get the length of the semicircle will be half the circumference of the circle. The length of the semicircle will be half the circumference of the circle, so it will be pi r. Half multiply the circumference of the circle, it will be pi r. Okay. A circle of a center M and the radius length r. Here the radius length is r, which is 14. The radius length here is 14. So here r equals 14. If A and B are 2 points on the circle such that measure of angle A and B equals 45, so this is the measure of the arc. Find the length of arc AB. Consider pi 22/7. Okay, so I want the length of the arc. The length of the arc equals what? Equals, yes, the measure of the arc over 360 multiplied by 2 pi r, which is the circumference of the circle. So it will be 45/360. Then I'll multiply it by 2 pi r. Okay, so measure of arc equals measure of length of arc equals measure of arc over 360 multiplied 2 pi r. Let's substitute. Here we have 45/360. This is the measure of arc and this is the measure of the circle. Multiply 2 multiply pi 22/7 multiply 14, which is the radius r. By calculating this value, it will be 11 centimeters. So the length of the arc measured by centimeters. Find the measure of the arc, which represents 2/5 the measure of the circle, and the length of the diameter. And if the length of the diameter of the circle is 70, find the length of this arc. Considered pi 22/7. How can we get the measure of the arc? This arc represents 2/5 the measure of the circle. It means 2/5 of 360. So to get the measure of the arc, just multiply this fraction by 360. So the measure of this arc equal 2/5 multiply 360. It will be 144 degrees. Now I want the length of the arc. It will be the measure of the arc over 360 multiplied by 2 pi r. R here is 35. Because the diameter is 70, so the radius is half the diameter, so it will be 35 centimeters. Okay, let's calculate the length of the arc. 2/5, this is the fraction, and this is the measure of arc over 360. Then I'll multiply it by 2 pi r. 2 multiply 22/7, and r, we said the diameter is 70 centimeters, so the radius is 35 centimeters. Then I multiply them to get 88 centimeters. So the length of this arc is 88 centimeters. We have some corollaries here. Number 1, in the same circles or congruent circles, the measure of arcs. If the measure of arcs are equal, then the length of arcs are equal. If we have, for example, measure of arc AB equals measure of arc DC, it means that also the length of the arcs are equal. Because the same radius, we said before here that they are the same circle or congruent circles, so R is equal. And we have equal measure of arcs, then if you apply in the rule, it will be the same fraction, measure of arcs over 360, it will be the same. Then I'll multiply by 2 pi r, so the only variable here is r. If r is equal, then the length of arcs will be equal. So in the same circle or in congruent circles, if the measures of arcs are equal, then the length of arcs are equal, and vice versa. Number 2, in the same circles or congruent circles, if the measure of arcs are equal, then their chords are equal in length. For example, here, measure of arc AB equals measure of arc DC. Then the chord AB equal in length equals to the chord DC. If the measure of arcs are equal, then their chords are equal in length. If we have two parallel chords, if two parallel chords are drawn in the circle, like here the chord AB and the chord CD, then the measure of the two arcs between them are equal. So the arc AC will be equal in measure to the arc BC, and also the length of AC will be equal to the length of BD, because they are two parallel arcs. If a chord is parallel to a tangent, here we have a tangent DC, this is a tangent, and we draw a chord parallel to this tangent, then the measure of the two arcs between them are equal. The arc EB equals to the length and the measure of the arc EA, because this tangent is parallel to this chord. Okay, let's take an exercise. And the opposite figure, the line segment AB and the line segment CD and the line segment EF are three diameters in the circle M of radius 3.5 centimeters. Find measure of angle of arc AD and the length of arc FD. Okay, let's see. Here we have AB, EF, and CD are diameters. I want the measure of arc AD and I want the length of arc FD. How can I do that? Okay, let's see. At first, I want to get the value of x. Here, for example, we have a diameter CD, AB, and CD and EF are diameters. I have the diameter CB. Here, this angle will be x, because the two vertically opposite angles. So this angle will be 180. It means 2x plus 3x equals equals 180. 2x plus 3x equals 180. 2 plus 1 equals 3 plus 3, so 6x will be 180. So each x I'll divide by 6, it will be 30 degrees. So x will be 60 degrees. Okay, measure of arc AD. This is the arc AD. This is the arc AD. It will be x plus 3x. It will be 4x. So 4 multiplied 30 will be 120. The length of FD. This is FD. The length of the arc FD. In this case, we will get the measure, then we will use the radius here 3.5 to get the length of the arc. Okay, so AD, the measure of AD will be x plus 3x, it will be 4x. 4x, it means 4 multiplied 30, so 120. Okay, now I want the length of arc FD. I'll get the measure of arc at first. It will be x plus 2x. X plus 2x, because this is 2x. Okay, so it will be 3x, which is 90 degrees. Now I want to get the length. The length equal measure of arc over measure of circle, which is 360, multiply 2 pi r. I have r here is 3.5. So I multiply 90 over 360. Okay, 90 over 360 multiplied by 2 multiplied by pi, which is 22 over 7, multiplied 3.5 will be 5.5 centimeters. So the length of the arc FD is 3.5 centimeters. So we learned that we have a measure of arc and a length of arc. The measure of arc is the same as the measure of the central angle, and the length of arc will be the measure of arc over 360 multiplied by the circumference of the circle, which is 2 pi r. Okay, let's continue. here I want to complete. At first we have AB, measure of arc AB. This measure of arc AB, this arc is 160. Measure of this arc is 160. AB is 160. Okay. Measure of arc CD, this arc is 100. So this is 100 degrees. I want the measure of arc AC. This is the measure of arc AC. Okay, measure of arc AC is the same as the measure of arc BD. Why? Because they subtended by the two chords AB and CD and they are parallel. So the measure of arc AC is the same as the measure of arc BD. So we will calculate the remainder of the 360 minus 160 minus 100. Then I divide it by 2. So I'll calculate 360 minus 100 plus 160. It will be then I'll divide it by 2, it will be 100. Then I'll divide by 2, it will be 50. So each one of the two arcs AC and BD will be 50 degrees. Okay, here I want the measure of arc BC. This is the arc BC. Okay, here the chord AB equals to the chord BC. So the measure of arc AB equals to the measure of arc BC. Here the central angle is 100, so the measure of arc AB is 100. It means that the measure of arc BC also is 100. Number 3, CD is a tangent. This is a tangent. It means that the measure of this arc equals the measure of this arc. They are equal in measure and also in length because we have the same circle. Okay, I want the measure of arc AC. This is the measure of arc AC. Here, what is the measure of arc AB? The measure of arc AB, of course, is the same as the measure of the central angle. The central angle here is 100. So the measure of this arc is 100. So I'll calculate 360 minus the measure of arc AB. So minus 100, it will be 260. Then I'll divide it by 2 because arc CA equals to the measure of arc CB. Okay, so I'll get 130 degrees. So today we learned what do we mean by a central angle. We said the central angle is an angle which its vertex is the center of the circle and the two sides contains each one of them contain a radius of the circle. And the measure of the arc is the same as the measure of the central angle subtended. Also we studied how to get the measure of arc and how to get the length of the arc. The length of the arc is the measure of arc over 360 multiplied the circumference of the circle. I hope you have understood our lesson today. Next session we will discuss the relation between the inscribed and the central angle subtended by the same arc. Thank you very much for watching. See you next session and goodbye.